Okay, let's start today's class. Today we will continue to talk about FS properties. Actually, we have already spent at least 3 classes on for FS properties. Actually, the FS properties are very important because it can simplify our computation for the FS coefficient and FS synthesis, like the signal synthesis, like that. That's the reason why it is so important. Okay, last Friday, we just have the online class, and I was afraid the online class cannot give you a very good explanation for the FS properties. So I just talk about the midterm 2, and if you have any questions about midterm 2, and you can email me or find me in the office hours. And yeah, let's continue to talk about today's class, FS properties. And for today's goal, firstly, we will review the symmetric properties, the linearity and time shifting properties, and the differentiation integration properties of the FS, and use them to simplify FS computation. Actually, the symmetric properties and linearity and time shifting properties we have already talked about a lot. Yeah. But the differentiation and the integration properties we just talked about in one class, and we have several problems left to talk about. Yeah, and after this, we will try to study the multiplication properties of Fourier series and apply them to simplify FS computation. And if we have enough time, we will try to study time reversal and scaling and conjugate properties and apply these properties to simplify the computation of FS coefficient. Actually, I don't think we have enough time for the time reversal, scaling, and conjugate properties. Yeah, but we will try. Okay. Firstly, let's review the symmetric property. Yeah, what's a symmetric property? Do you remember? Yeah, actually, the symmetric property, which means the FS coefficient, it is conjugate. Yeah, it is conjugate numbers. It's not real numbers. So for the FS coefficient, there are some symmetric properties for it. And firstly, we talk about for the real signal. What's a real signal? Real signal, which means it is xt equal x conjugate t. Yeah, we talk about y. And if you don't remember, you can review the class before the previous class. And for the real signal, the xt equal x conjugate t. And then the FS coefficient is ak. And we have this conclusion, ak should equal a negative k conjugate. Yeah, we call this one conjugate symmetric. And then for the time reversal, which means if we have the xt, the coefficient is ak, and for the x negative t, the coefficient is bk, and we have the relationship between ak and the bk. The bk should equal a negative k. Okay, and then for the even signal, and xt equal x negative t, am I right? Yeah, and this is even. And what's the relationship between what's the relationship for the FS coefficient? Do you remember? Actually, the ak should equal a negative k, and we call this one even FS coefficient, which means if you find the ak equal a negative k, which means your signal is even signal. That makes sense to you? Okay. And then for the odd signal, which means the xt equal negative x negative t, and the ak should equal negative a negative k. We call it odd FS coefficient. And if the signal is real and even, which means those equations works together at the same time. And then we have ak equal a negative k equal a negative k conjugate. Yeah, which means if you observe this, we found that the real and even, right? And which means if you find the A key equal A negative key equal A negative key conjugate, which means that your signal is real and even. Okay, and the next one is real and odd. Yeah, if your signal is real and odd, you have this relationship for the FS coefficient, the A key equal negative A key equal A negative key conjugate, which means if you observe it and the FS coefficient, it is imaginary and odd. Yeah, that makes sense to you? Okay, and then this is a symmetric property. Actually, for the symmetric property, you can easily to tell like what's the if you for example, if you know this like a signal is real signal and it is a even signal, and you can easily to get the like a negative key and a negative key conjugate based on because you know a key usually. Okay, and also you can observe the FS coefficient and tell what kind of signals you are dealing with. Yeah, for example, if you find the FS coefficient is the A key equal A negative key equal A negative key conjugate, and which means your signal is real and even. Am I right? Okay, and the similar for the for this situation. For this situation, yeah, if you find the A key equal negative A key equal A negative key conjugate, which means your signal is real and odd. Okay, let's try to talk about the linearity and the time shifting. The linearity, which means if you have two signals, xt and yt, and both are periodic, and for the xt, the fs coefficient is ak, and for the yt, the fs coefficient is bk. And then if you have a new signal a xt plus b yt, a and b can be any real number. Yeah, and then for the new signal, you have the new fs coefficient. It should be ak plus b bk. Yeah, actually you can prove it using the equation. Yeah. Okay, for the time shifting, which means if you have a signal xt and the fs coefficient is ak, and which means for the xt minus t naught, you have the fs coefficient ak multiple this part. Yeah. Yeah, and this part we call it linear phase shifting, because you can see the AK actually include two different information. One is magnitude and the other is phase. Am I right? Like this one actually it just give phase a shift. Yeah, that makes sense to you. Okay, and then okay, sorry, I think I just yeah. Let's talk about the differentiation and the integration. Actually, if I give you a periodic signal xt equal xt plus capital T, which means the period is capital T, and then the AK is fs coefficient for the xt, and its derivative has a fs pair zt after derivative, and you get the new signal zt, and the fs coefficient d is dk, and then we know the dk should equal this one, and you should multiply this part by ak, and then you get the new fs coefficient for the derivative xt. Yeah, and then for the integration, like we talk about the a naught for the signal xt, the a naught must be 0, otherwise you cannot use this property. Yeah, and if a naught equals 0, it's integration signal yt. It's also periodic with fs pairs as this one. Yeah, yt equal integration of the original signal xt, and then the new fs coefficient ck should equal this part. And then we talk about the ck must be equal 0. And do you remember why? Yeah, actually we know that this is xt, am I right? The original signal. Yeah, and if we want the original signal like after integration, and it is periodic, which means what? Which means this part, A now, must be 0, am I right? And if for the xt, there is no like a constant atom. After integration, there must be no constant atom. That makes sense to you? So that's the reason why ck also equals 0, because no, A now equals 0. Okay, let me ask you one question. Do you know why A now must equal 0? We talk about it. Yeah, because we want yt also periodic, am I right? Yeah, after you integrate it, integrate xt, yeah, which means if you integrated, yeah, if you can see the xt equal like a now plus some like k equal negative the infinite, yeah. Or like A K constant plus B K constant, blah, blah, blah. Yeah. Actually, I think this is one, and also plus negative is equal negative equation to the like of 0. Okay, equal negative 1. Yeah. And A to the blah blah blah. You can see this part and this part, it is periodic because it's related to the sinusoidal system, right? And this one, actually, you can see the sinusoidal system plus a constant value. What does that mean? Which means the magnitude will change, am I right? Yeah, sorry. The magnitude will change. Yeah, this is yeah. For example, you have a sinusoidal signal, blah 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 blah. This one, if you plus a constant, which means the like the full diagram will upshift or downshift. Doesn't make sense. If it is positive, it will like a downshift. If it is negative, it will positive shift. Does it make sense to you? Yeah. If it is a positive, it will upshift. Yeah. And it will become this one. Become this one. Sorry, become this one. Am I right? It's still periodic, am I right? But after you integrated the constant value, it should become if you integrate a constant value, what you can get? Yeah, for example, it is 1, am I right? From positive to negative, it will increase. Does make sense to you? So this signal actually obvious is not carried, am I right? If you have the some thing, if you add this one, it will become this one, maybe this one. It's obvious not periodic, am I right? So that's the reason why we just want the A now equals 0. That makes sense to you? Yeah, if you have any questions, just let me know. Okay, then the CK, because the A now equals 0, which means there is no constant atom. After integration, there is still no constant atom, am I right? Yeah, so we have this Fs coefficient after integration. Okay, and we want to here we want to talk about some examples to let you understand the differentiation property and the integration property. And before we talk about the examples, we talk about two often used Fs pairs. Yeah, one you can see one this signal. We know like this signal. What are the Fs coefficient for those two signals? And for the first signal, we know like the signal can be read like this. That makes sense to you? Yeah, we talk about it a lot. Yeah, and what is the Fs coefficient for that? Do you remember? Yeah, it should be 1 over t. And for the second signals, and we know the A now should equal to 2 t like 1 multiple or like divide t. And then the AK should equal this one, sin omega naught k. P1 over P-pad. Actually, yeah, for this kind of signals and the A0, actually you can use the sand area divided period to calculate it. And we talk about some like examples like in the previous class. Yeah, if you have any question, just let me know. Okay, let's continue. Okay, I think okay, let's talk about this signal xt. Yeah, and this xt we suppose the AK is fs coefficient for xt. And okay, let's try to observe this signal. Sorry. Oh, sorry. Let's try to observe this signal. What's the period? You can see, you can like know the period from here to here, or from here to here, or from here to here. I'm right. It's obvious too. I'm right. The period should be 2, and the A0 should be 0. Yeah, that makes sense to you. Yeah. Why? Do you know why the A0 is 0? Because you can see the sand area is this. The in one period is this area and this area. After you plus this and it is 0, I'm right? And then you over 0 over t is still 0. Okay, then if we use the like we use the equation like the what equation we should use? Signal analysis, am I right? Yeah, actually this is the signal analysis equation. If we use this one and we just try to put xt here and the harmonics component here and the dt, and then we use the integration equation, and we will find the equation will equal this one. Yeah, because here you just put t equal to like into this one, and then because the xt is you can see it's just like a line, am right? You can easy to, this is obvious t, am right? In one period, this is t. Actually, you can, if you write it down, it is xt equal t. Am I right? Yeah, so this is just the, you can write this equation, t multiple e g blah, 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 blah. And then you can put this part out. And then this is t, blah, blah, this part and this t, this part. And then this part, yeah, this part, you can easy to write it like this. Put a t here. Put a t equal 1 here. This is just e g e negative g k pi, and this put a negative 1 here, and it's this part. Does it make sense to you? Yeah. And then if you use the Euler equation, you can get this one and then this one. Am I right? And for this part, and you can try to use this equation, and then step by step you will find this one, and it will be 0. So your AK should use this part multiple this part. Does it make sense to you? Yeah. So and then you will find your final result equal this one. That makes sense to you? Okay. If you have any question, just let me know. Yeah, you just put t here. And then you just try to, because there is a divide, so you just try to divide, which means it is minus, am right? You just try to divide it and then into two different parts, and then step by step you get this one. Okay, then you will find out it's quite complicated, am right? Yeah, and do we have a easier method for this equation, for this question? Yeah, we have. Yeah, and then yeah, this is just a final. Oh, okay. I think I just missed this part. Yeah, and this is just like a AP. Yeah, you just put AP equal here and equal here equal here. Yeah. But it's the same thing. Yeah, because T ST is T, and you put it here, and you just use Yeah, t. Yeah, you just use some equation. Yeah, you should use the integral equation to calculate it, then get this one. Does it make sense to you? Okay, and then, but actually we have an easier method for this equation. You can see this is our signal, am I right? We know like the period is 2 and the A naught is 0. We have already know that. And then you can see if you derivative this equation, and you can get this one. You know why? Yeah, because for the lab, for the lab, and then you will have a constant after your derivative. You have a constant value. Let me give you an example. For example, sorry. Y equal AX. Am I right? This is a line equation. After you derivative, actually is equal what? It equal A. Am I right? Yeah, you can see for every line part, it's the same thing, which means for this part, it always A. We just try to write it A. A can be any number, it depends. Okay, and for this part, you can see it is just from 1 to -1, drop to -1. For the huge drop, we have after your derivative, we have this one. Am I right? I think you learned this some class, some mathematics class. Yeah. And for the if you have this if this line after your derivative, it's an impulse. Yeah, because it's from positive to negative. Yeah, it should goes down. If it is from negative to positive, yeah. For example, it's just like this. Yeah, this and this. It will be goes up. Does that make sense to you? So this is like a xt after derivative. Yeah, we can get this equation. We can get this figure. Okay. Yeah, for this figure. Yeah, we know like this one is a constant. Am I right? This is just a constant. Am I right? And for this one, what you can think? Yeah, for this part, what you can think? Yeah, that too often used like FS pairs. You can see we have this one, am I right? And this one we have the BK equal 1 over T, am I right? Yeah. So here let's talk about what is yeah, for this one the period also T, am I right? The period is also 2. And for the HT, we have the 1 minus 2G T, like a -1, am I right? Do you know why? Because here is 1, here is 2. Yeah, here is 1, here is 3, am I right? Here is 5, am I right? And for your original one, and this is just like 1, 2, am I right? So which means you don't have this one. You need to like right shift or left shift. Actually here, -1 or like a -1 or +1, it's the same thing. Yeah, so you just like try to -1 to do a like a right shift, and then you have this yeah this one. Actually, you have this one and this one and this one. Am I right? But here you can see it doesn't go up, it goes down. So which means you need to flip, am I right? So this is why here there is a negative. And 2, because here this is 1, am I right? But here this is 2, because from -1 to positive 1 to -1 is 2. So you need to have there is a 2 and a 1, because this is 1. That makes sense to you, because this is just a the like slope, am I right? The slope is 1. So it's 1 plus this part, because this is negative. So 1 negative, 1 minus 2g. That makes sense to you? So what we can do? If we know the fs coefficient for ht, and then like the ck, am I right? After because the ht is just like a xt after derivative, am I right? After derivation, and we can integration. After integration, we just like get the xt, am I right? It's just opposite operation, am I right? Yeah. So for the constant like term only affects c naught. All the like a naught, yeah, because that makes sense to you, because it will not affect the other atoms. Yeah. So yeah, we know like the g t minus t naught equal this one, because what properties? What properties? Yeah, fs like the like a shifting property, time shifting properties. So we have this one. The ck equal negative 2 bk e gk e gk pad. Yeah. Okay, this one. I'm right. Yeah, because do you know why? Do you know why like the one disappear? Because the one only affect a naught, the c naught, which means the only affect the c naught. It will never affect the ck. Yeah. It will never affect other atoms. So yeah, so we only care this part. That makes sense to you? Yeah. Do you know why? Yeah. Do you know why? Okay. Yeah. Think about that, and we will talk about in the next class. Okay. And then you can see the key should not be 0. Yeah. And then if you want to get the fs coefficient for xt, and which means you need to do an integration for the ht. If you do the integration for the ht, which means for the fs coefficient, you need to multiple this part. That makes sense to you? So which means you need to multiple this part. Am I right? Yeah. That makes sense to you? Yeah. Like multiple this part, which means divide this one. So you just divide this one, and then you get this one. And yeah. And any question? Yeah. So you finally get this. That makes sense to you? Yeah. Here t cannot equal 0. That makes sense to you? Okay. And any questions? Yeah, because here we have the A0. Yeah. So AK equals this one and A0 equals this one. That makes sense to you? Okay. Let's talk about the other one. For this one, yeah, the XT, the signal is XT and the FS coefficient is AK. And then for this one, do you have any ideas what we can get? Yeah. Actually, you can see for this part, what we can, yeah. Actually, you can see, firstly, let's try to talk about what's the period. Yeah, the period should from here to here, am I right? It should 6, am I right? What is A now? Actually, we talk about that. It's area. It is 1/2, am I right? And so, actually, you can see after you derivative this part, you can see after your derivative, only this one has a constant value. This one, because it's constant, which means if you have the y equal a is a constant value. After your derivative, it should be 0. Am I right? So which means this part is 0. Only this part has a value. Am I right? Yeah. So similar thing. Yeah. This one, we can think about this one. Am I right? Yeah. So we know like for these signals, the fs coefficient is this one, am I right? And here we need to try to represent ht with gt. Yeah, that makes sense to you. So which means the t equal 6, am I right? The t1, what's t1? Actually, t1 is 0.5, am I right? Yeah, because you can see it's a similar thing. And the 0.5 should move to the 2, which means it will should like a left shift or right shift 1.5. That makes sense to you? Yeah. So which means you let it like a left shift 1.2 to this one, and also right shift to here. Am I right? But you can see this one is down, which means you need to give a negative. Am I right? Yeah, this is if we want to find the C key for this fs coefficient for this signal. Yeah, actually we have this one, am I right? So we can use it to get this one. Yeah, based on what property? Time shifting property, am I right? So yeah, and if you know this fs coefficient, actually for this one, you just integrated back, am I right? So which means you have AK equals CK divide this one. So for now, you need to calculate the CK, am I right? CK, we know that it is, yeah, this is just like try to put a T here, and then you get this one, and then try to figure out what is CK. Actually, it's very easy after using time shifting property, and then you can see, you can easily get the first part and the second part, and then you can easy to get CK. That makes sense to you? Okay, if you have any question, just let me know. Okay, let's try to discuss more. And we have the other example, this one. Actually, this signal, yeah, we have this and what period? It should be 3, right? From the -2 to 1, am I right? 1, 2, 3. Yeah. And then what's the area? It should be 1, am I right? So after you derivative this one, you can get this one. Yeah, because you can see only, yeah, this is line. So which means you get a constant. And this is the other line, you get a constant. Am I right? Constant value. Yeah, so this is after your derivative. And okay, which signal we need to use? Yeah, this one, am I right? Yeah, actually here the point becomes we need to use the GT to represent the HT. That makes sense to you? How? Have you had any ideas? How can we use the GT to represent the HT? Yeah, actually you can see if you try to shift it, am I right? And then you will get this one. Yeah, this one. Are you familiar with that? This one? Yeah, it's very similar to this one. That makes sense to you? Yeah. Okay. And then, yeah, which means actually there are two different methods. The first one is you just try to try to shift this GT left with 2 units, am I right? Which means here the T1, firstly, the T1 should equal 1 because the total is 2, am I right? So this is 1. So which means you need to move the 1 to like move the 1 to 3, am I right? Move the -1 to this part. That makes sense to you? Which means it should be -2. Am I right? So which means this is just try to move this to the to left 2 unit, and then yeah, because this is 1 and this is 3, so you need to multiply 3, and since you need to up, so which means you need to from after you move this and you need to down, so you need to divide 2. Am I right? That makes sense to you? And then after you use the integration like properties, you can easily to get AK. That makes sense to you? So, and for the other method, actually, you can see, you can just shift this one. Let's try to, yeah, this is HT, am I right? And then you try to shift it, then become this one, am I right? Which means you can use this equation. Yeah. This is just the G, try to move 1.5 unit, just like the method I talked about just now. And then try to multiple -3 because you need to like, yeah, you can see this one, you can see it's just a narrow it, am I right? Yeah. That makes sense to you? Yeah. You just try to no upshift, just a downshift. Yeah, and try to multiple one, and then if you get this one, and you can totally represent HT using this equation, am I right? And then you can use the first method. You just use the first for this method, you firstly and you just use GT and to find the HT, and then use the integration property to find the XT, and then they have you have this relationship for the FS coefficient. That makes sense to you? Okay, and if you have any question, just let me know. Okay, actually there is a math tip like from FS coefficient to a DT signal. You can see from a set of FS coefficient AK, like we have AK and there is a DT digital AK. Actually, you can represent FS coefficient with a DT signal AK. You can see, for example, this is your FS coefficient. Usually we use this, am I right? Actually, you can see if you draw it, this is AK. This is your like FS coefficient, am I right? Actually, you can use a equation, yeah, to represent the AK, which means AK equal to delta K plus 1 plus K delta K minus 2 delta K minus 1, right? Yeah, which means, yeah, do you know why? Yeah, because you can see here, if it is 1, which means K equal -1, am I right? And it will be 2. And here, K equal 0, it is 1. K equal 1, it is -2. Okay, and then you can see we can represent the FS coefficient with a DT signal. That makes sense to you? Okay, and from a DT signal AK to a set of FS coefficient, which means if you have this AK like a representation, you can easily to find the A now, A -1, A1, A -2, A2. Am I right? Yeah, because here, which means the key should start from -2, am I right? When key -2, and you can see observe this one and this one, it has the same coefficient, which means it is 2. And this one and this one, it has same coefficient, it is -1. And this one is A now equal, it is 3. That makes sense to you? Okay. And then based on this, let's talk about multiplication properties. For the multiplication properties, and similar thing. Yeah, we have two different signals, ST, YT, and the FS coefficient is AK, DK. And you can see the XT, like this since those two signals are periodic, so they have these properties. And we know like if you multiple XT and YT, which means like and for the FS coefficient, actually the FS coefficient equal this one. The AL is just like the FS coefficient for XT, and the BK, yeah, it's the FS coefficient for the YT. Yeah, are you familiar with this one? Actually, you should be familiar with this one because this is DT convolution sum. Do you remember? Yeah. So actually, this is, let's recall the convolution sum, which means if AK multiple convolution with BK, then you call this one. This is the convolution sum equation we talked about before. Am I right? So which means for the new fs coefficient, it equal the old two ones convolution with each other. Yeah. Which means, yeah, this is the AK. Yeah, because the AK can be represented like this, and the BK represented like this, and the CK and it can be represented like this. And this is just the new fs coefficient for the AK and the CK. Actually, new for the like xt multiple yt. Actually, this property is very important for signals and signals and system deal with, because you know what? If you want to like if you want to get the filter the specific frequency, yeah, which means you need to do a, yeah, which means if you do a multiplication in a time domain, which means you do a convolution in the frequency domain, yeah, you can use this one to get the specific frequency. Yeah, actually, this property is very important for the signals and system operation. But here, we just talk about the theory thing. You don't have many feeling about that. But yeah, this one is very important. Okay, and let's talk about one example. Yeah, consider the following three signals with t equal 0.5. Yeah, this one is like xt, yt, and zt is xt, multiple yt. Yeah, let's try to determine the fs coefficient of xt and fs coefficient of yt, and then determine the fs coefficient of zt using fs properties, and determine the fs coefficient of zt using the directly expansion in geometrical form. Okay. Yeah, this is Euler equation. We know that, right? And then let's continue to talk about that. We know like the new signals, the CK, the equal AK multiple convolution with BK, am right? So for the like XT, yeah, you know, yeah, you can use Euler equations, and then you will find the only the A1 a negative one has values, and then for the xt, the AK should equal a negative one, this one, and A1, this one. This is for the xt. And for the yt, actually, you can see this is similar. One is cosine and the other is sin. It only have the two atoms for the fs coefficient. And then for the bk, you can represent the bk like this. And then we know like the ck equal ak convolution with bk, am right? Which means it equal this one convolution with this one. And then some properties we can use. But these properties just try to pay attention. This property is not fs coefficient, fs properties. This one is convolution properties you usually use. What convolution properties you usually use? Yeah, the distributive properties and the shifting firstly, let's try to use the distributive properties and multiple them. Yeah, and you can get this one and this one. Yeah, actually, this is just after distributive and the time shifting properties. You can get this one, this one, this one, this one, and then you can see this one and this one is the same atom. Am I right? So we can put them together like this. And then you can see this is one key equal -2, and this is key equal 0, this key equal 2, am I right? So which means this is C -2, this is C naught, this is C2. Okay, that makes sense to you? Okay, any question? Okay, let's try continue to talk about that. And we know like the ZT equal XT, YT, so it's equal sin this one cosine. And then we know this equation, am I right? So which means this we have this one. And then using Euler equation, you can have this one. That makes sense to you? And then, yeah, this one. And we know that the t equal 0.5, which means omega equal 4 pi, am I right? So which means this is just like the -2. And this is just -2, and this is k equal -2, this is k equal 2. Am I right? So this is just to verify the multiplication property we just talked about. Does that make sense to you? Okay, let's continue. Okay, I don't think we have time for the time reversal and the time scaling properties. So let's stop here. And today we mainly review the symmetric properties and time shifting linear properties, and then we talk about the new properties multiplication. Yeah, actually this one is very important. So just review it. If you have any questions, just let me know. Okay, thank you.